This video is on how to do a hypothesis test for a two-sample study. It is in Module 2, Comparing Groups. We will look at doing a hypothesis test in the context of study example 1. Remember that we are comparing the sleep hours of students who took AP or college courses and those who did not take AP or college courses. Remember that our null hypothesis assumes there is no difference between the two groups, while the research hypothesis proposes that there is a difference. Therefore, our null hypothesis is that the true difference in mean sleep hours for high school students who did not take AP or college courses versus those who did is 0 hours. This is the same as saying that there is no difference in sleep hours between the two groups, or that their means are equal, or that the difference of their means is 0. Therefore, our null parameter is 0. The research hypothesis is that the true difference in mean sleep hours for high school students who did not take AP or college courses versus those who did is not 0 hours. That is, there is a difference in sleep hours between the two groups, or that their means are not equal, or that the difference of their means is different from 0. The test statistic takes a similar form to the test statistic for a one-sample study. The numerator consists of the point estimate minus the null parameter, and the denominator consists of the standard error. In this case, the point estimate is the difference of the sample means, and the null parameter is 0. For the two-sample study, the null parameter is almost always 0. The standard error calculation depends on the results from the F-test for equal variance. From the estimation lecture, the variances were unequal, so the standard error calculation is what was found in that lecture. However, we don't have to do this by hand. STAT+ in the Analysis Toolpak will calculate a t-test assuming equal variance or unequal variance. The results on the slide will be formatted similarly no matter which software you use. The test statistic is labeled as t-stat, which is 3.36. Since the research hypothesis is two-sided, not equal to, we are interested in the two-tailed p-value, which is on the next to the last line. The p-value is 0.0008. Remember that if the p-value is less than the significance level, 0.05, then there is enough evidence to reject the null hypothesis. Otherwise, the null hypothesis is not rejected. We compare 0.0008 to 0.05. Please pause this video now and determine whether 0.0008 is greater than or less than 0.05 and what the conclusion would be. Since 0.0008 is less than 0.05, we reject the null hypothesis. There is enough evidence to conclude that there is a difference in the true mean sleep hours between high school students who did not take AP or college courses and those who did. If the outcome isn't normally distributed, we have an alternative to a t-test. In this case, the non-parametric test is called the Wilcoxon or Mann-Whitney U-test. More information can be found on the listed pages in the textbook, by using Google, or by asking me. Let's review study example 2. Remember that we are comparing sleep times of college students based on their class standing. We are dividing the students into two groups. Based on this information, what do you think the research hypothesis should be? Do you think those with a higher class ranking would get more sleep, less sleep, or a different amount of sleep than those with a lower class ranking? Please consider this thoughtfully before moving on to the next lecture. In Concept Practice 6, you will do a two-sample t-test for the difference in average sleep hours from this example.